Yeah, so did you try these three questions which I had given you in the last class? Did you try these three?
Actually, no, I could not because I was having stay back this week. So,
Again, those stay back. Yes, let us try these.
but the questions before this exercise, I did all of them. So,
Good, yeah, good. Okay, yeah. So now let us try these ones, right? And I will tell you that whenever you have any difficulty in these trigonometric identities, so the ultimate
yeah,
and
and also, sir, is it possible if you could give homework like every Thursday so that I have the weekend to complete it?
every Thursday.
Yeah, because like here weekend is on Friday and Saturday, so I can like do the work during the weekend. Because we have Saturday classes also and like stay back, so it's a lot of burden. So just
Okay,
can't
yeah.
complete.
Okay, so I will convey your point to the Learnivio team because I sent them those homework. So yeah, what I will tell them that yeah, send you those homeworks on Thursday, right? Or maybe we can yeah, so we can change the due time, right? So due
Change
time,
that?
yeah, we can change the due time, right? So,
Yeah.
yeah, so that we can also. So let's say that I give on Thursday, right? So on Thursday, yeah, on Thursday we have oh yeah, today. So let's say I give the homework to you for this day, and they you will submit those homeworks on which day? On maybe Tuesday.
So what?
Yeah,
Submit it on.
yeah, yeah. So let's say I assign some work to you on that Thursday, right?
Yeah.
Then what is the time that you will be able to complete those things? Maybe Sunday. Sunday, would that be okay for you? Sunday, up to Sunday.
Yeah. Sunday is fine.
Yeah. So then you will send those works on Sunday, and then I will talk about those works on Tuesday. That would
Okay.
be that would be right. Yeah. So
You can just inform the learning.
yeah, yeah. So I will convey your message to them, and yeah, that's I will welcome. Yeah. So what I was going to tell you that in this trigonometric identity, the ultimate idea or the key idea, whenever we are stuck at some question, so the key idea is that write every ratio, write every ratio in the form of sine and cos, and then simplify. So this is the ultimate that you can apply for every question. Okay. So whenever you are stuck at some question in trigonometric identity, use this. Write everything in the form of sine. Okay. Yeah. So now this was the second. So we see that this is tan and sec. This is cot and cos. So these are mixed ratios. So we will use this side. Right? We will write everything in sine and cos. So what is tan theta? What is tan theta? Yes, what is tan theta in the form of sine and cos?
The ratio or the identity?
So tan theta in the form of sine and cos, right?
Yes, so tan theta is equal to 1 minus 1 plus sec square theta.
Oh, that is tan square theta is sec square theta minus 1. I'm asking about tan theta. What is tan theta in form of sine and cos? What is that? Tan theta is sine theta by cos theta, right?
1 by sine theta.
No, sine theta by cos theta. That is the tan theta, right? Right? Do you remember it now? Tan theta is sine theta by cos theta, and cot.
Wait, is this a identity?
Yeah, we can call this as an identity, right? So this relates tan theta, sine theta, and cos theta. So we can call this as identity, right? So yeah, tan theta is sine theta by cos theta, right? And cot theta is cos theta by sine.
No, but you only give three identities in that we can
Yeah, so
do it the other side, but here you give various information.
yeah, this thing is already right. This thing we have already. This is another crucial property that we have, that I have mentioned. Okay, so if I have not mentioned somewhere, then these right, then right. Yeah. So I have written. Yeah. So please note it down that sine theta is tan theta is sine theta by cos theta. Right. From here you can also, yeah. So please remember that tan theta is sine theta by cos theta, and cot theta would be reciprocal of that. So this would be cos theta by sin. Please write it down and right. This is very crucial. Okay, so we can write tan theta as sine theta by cos theta. And what is sec theta? Not the identity. What is sec theta? In the form of sine and cos. What is sec theta? Yes. What is sec theta?
So, um,
Sec theta is related to which one? Sine and cos. Which one is related with sec
um,
theta?
sec theta is a cos by
Yeah,
sine.
cos by sine. Cos by sine is cos, right? So sec theta is reciprocal of cos theta, right? So 1 by cos. Here, and cot theta is cos theta by sine theta. And cosec theta is how much? Cosec theta is how much in the form of
The
which one?
reciprocal of sec
Sec. Reciprocal of sec is cos.
cosec, right?
Yeah, cosec is reciprocal of
Um, cos.
cos. The all cos. You just remember the trigonometric ratios, right? Sine theta is E by H. Cos theta is E by H. and tan theta is by. If I ask that what is the reciprocal would be h by p. What is h by p? What is
It
h
is H by P is cos.
cos?
Mm.
Cos is p by h, right?
No, it's cos.
Cosec, right?
Yeah.
This is sec. This is p by cos. Always remember that sin theta is reciprocal of cosec, cos is sec, tan is cos. These are the ratios, right?
Okay, it was the reciprocal.
Yes. So then cosec theta would be how much?
Cosec theta is H by P, which is
So
sine.
1 by sin. Reciprocal is 1 by, right?
1 by.
So we have written everything in the form of sine inverse, right? The question was this thing, but we have written everything in sine inverse, and then we will simplify. So, but to solve these three terms, we have to take the LCM, right? So LCM would be what? 1 cos theta cos theta. So what would be the LCM? What would be the LCM of these three things?
We have cos theta and cos theta. So is should we write the ratio or the identity?
No. So we have to simplify these three things. So we have to take the LCM. 1 cos cos. So these
Oh,
are
it's
fractions.
cos square theta.
Cos square. So if I take the LCM of cos theta, so I divide this by cos theta, so 1, 1. So then this is 1. So LCM of cos theta, LCM of 4 and 4, how much is that? That is 4,
2.
right? So LCM would be cos theta. So this is cos theta, this is sin theta, this is 1. Right. Similarly, we have this thing. So again, LCM is sin theta. So this is sin theta plus cos theta minus 1. So now this cos theta and sin theta we can multiply. And what is this? So if I assume this thing as A, right, and this thing as B. So what is this thing? What is this thing? A plus B and A minus B, right?
Yeah, that's A plus B identity.
So that would be how much? That would be A
A
square.
square plus 2AB plus B square.
No, not A minus B, A plus B. So that is A square minus B square, right?
No, but you said we are using A plus B identity, right?
Yeah. So A plus B, A minus B. How much is that? A plus B, A minus B.
That is A square minus B square.
Yeah. So A square minus B square, right? Yes. Yes, is this thing clear?
Yeah, but yeah, is it possible if we use A plus B the whole square for the first one cos and for the sine we can use A minus B the whole square?
How can we use A plus B? Do we have any square in there? Do we have any square? Where do we have any square? So to use A plus B whole square, we need
So we are like solving both of them together.
yeah. So we are solving these two products, right? This is this is sine theta plus cos theta plus 1, and this is sine theta plus cos theta minus 1. And I'm saying that let's write sine theta plus cos theta as A, 1 as B. So this would be how much? That would be A plus B. This thing is A plus B, and this thing is A minus B. So this would be how much? A square minus B square. A is what? A is sine theta plus cos theta. So that is A square minus B is 1. So that is what this thing is. These two are products, right? This multiplied by this is the thing clear.
Yeah.
This is how much? So now this is A plus B whole square, right? This is A plus B whole square. So A plus B whole square is A square plus B square plus 2A and B and minus 1 divided by sine theta cos theta. So what is this thing? Sine square theta plus cos square theta. How much is that thing?
1.
1. Good. This is 1, and which thing is cancelling? In the numerator, which thing is cancelling?
We cancel the sine and cos.
These are three different terms. Plus is there, minus is there. So whenever plus and minus are there, we cannot single out, right?
No, I mean like bottom we have sine and cos, right? So we can cancel.
Do we have any sine and cos in here? Do we have any sine and cos in here?
No, we don't.
So these are not common. Sine and cos are not common in every term, right? So we cannot cancel with these, and these are there. But in the numerator, 1 and minus 1, these we can cancel, right?
Yeah.
So now if it is cancelled, then we can write this thing as. So now we can cancel this right? So the answer to this question would be, please note down this thing, and if you have any doubt, please, note down this thing, and if you have any doubts, please.
Yeah, one more thing here, you use A plus B, A minus B, which is A square minus B square identity.
Yeah.
So I plus B minus 2.
Yes. What?
Use here we use A plus B, A minus B, I mean A square minus B square identity, right? So
Yeah.
after that, you just put sine theta and cos theta like that.
Okay.
Shouldn't it be sine theta plus, minus cos sine square theta minus cos square theta? Because we use A square and B square.
Yeah. So you are telling me that yeah, which part?
After this after the second part.
This part and yeah, this part after this part here. This, right. This was
Yeah. Well,
part.
how did you get plus?
Okay. So yeah. So you see that what is the A that I have assumed? I have assumed that this is my A, right? And I have assumed that this is my B. So if I write A square, so A is what? What is A? A
A
is
is sine theta plus cos.
A is this. So this would be this square minus B is what? 1. So this is what I have written, right? This is
Okay, so
clear.
in the other side also A is sine theta plus cos.
The
Like
other
the other side is the the
which side?
this one, like after the B, yeah,
Yeah,
that one.
yeah. So A plus B, that is the identity. A plus B and A and minus B. This is the identity that we are. Or if you have a doubt in this identity, then we'll have to multiply all these, right? So then we'll have to multiply everything and get the answers. If it's not clear, then we can multiply everything, and so then this would be multiplied with everything, and then this is multiplied with everything, and this one is multiplied with everything. So we can do it in this way, but it will take a lot of time. Right? Nine theta nine theta cos theta minus sine theta plus sine theta plus cos theta minus cos theta plus cos theta sine theta plus sine theta cancel. And this is sine square theta cos square theta, so 1 cos theta sine theta cos theta, so sine theta cos theta and minus 1. So we'll get the same result as right, but it will have a larger this would be less. So either you use this thing or you use identity.
Yeah,
So
and see also over here you said you can't cancel sine theta and sine theta, but you cancelled it after the two, like after cancelling one, you got two sine theta cos theta by sine theta. You cancelled it, right?
which one I cancel? Which one?
The the two sine theta cos theta. That
In here.
yeah.
So now in here you see you have 2 into 3 into 4 divided by 6. All these are in multiplication, right? So then we can cancel these. But let's say you have 1 plus 2 into 3 into 4 plus 3 divided by 2 into 3. So then can I cancel this? I cannot because this is 1 plus and 3 is also right. So
Okay.
I had this thing, that is why I can. Because no other term, all these are in multiplication. There is no addition or subtraction in the subtraction. So that is why I can. This is clear. Yes.
Yeah, it's clear.
And what
Hello.
about, yes, yes, what about the identity part? That is clear. Is that clear or not? So you,
Yeah, it's
yeah, so you can use this thing or you multiply it. Both, both ways we get yeah, please note it
So
down.
in this exercise, I thought we'll be using the identity, but
Yeah,
we
so
use the resource.
we have used the identity, right? Here we have used
Yeah,
the identity.
only.
Yeah, so not every time you use the identity, but in some sections you use the identity, right? That is the purpose. So how we can simplify using these identities. That is the purpose of it. Get in some patches, we get to use this identity. Yeah, so put it down. Down. Yes, noted.
Yeah.
Yeah, so now let us move on to the next. So next question is so again this is a mixed question. So the key idea, the ultimate idea is what you write
Same
everything.
like the first one.
Yes,
It's same like the first one.
yeah. So no, this is right, but we'll use the
No,
same
not the first one. I mean like the previous one.
second one. Yeah, yeah. So previous one, yeah, we have to use the same idea. Yes, same idea every time we will use it. Same idea. Again, we see that this is a mixed question, mixed ratios question. So we will write everything in sine and cos. So what is the sec? What is the sec?
Sec is 1 by cos.
1 by cos, right? 1 by cos A. What is tan A?
Mm. Tan is 1 by cot.
In the form of sine. We have to write everything in the form of sine and cos. Right?
In the form of sine.
Sine and cos, right? In the form of sine and cos, we
Oh,
have to write
tan is sine. Yeah, sine theta by cos.
sine A by cos, right? Okay, and this one is already in the form of sine. So now we have to take the LCM in here, and this would be how much? 1 plus sine A. And
And cot theta is the opposite of it, right?
yeah,
Cos by sine.
cos by sine. Yes, absolutely. Right. Now what is this identity? A plus B, A minus B. So what would be this thing?
A plus b, a minus b is a square minus b square.
So 1 square is 1 minus B square, right? So what is this thing? What is 1 minus sine square? Take the
So
identity. What is 1 minus sine square? Yes, what is 1
1
minus
minus sine square is a cos square.
cos square? Right, every, yeah. So 1 minus sine square is cos A. So we see that 1 cos A will cancel. Then put it down, and if you have any doubts, please.
So we have to memorize the identities, right?
Yeah, so that is very because the exercise is all about the identity, right? Only three identities are there, and yeah, and we have to use those three, right? So all the others are dependent upon or derived from that. So we have to just remember the three identities.
Mm.
Yeah, noted.
Yeah.
Next question. So we know that tan square A is related with some identity. So what is 1 plus tan square A?
Tan tan is six
This is very good. So this is 6 square A. Similarly,
and cot
what?
is cosec.
Right. And we know that sec is reciprocal of cos and cosec is reciprocal of sine. So this will go in the top, this will come down. So this will be sine square A divided by cos square. So this will be tan square. This, these are noted down and then we move on.
This is the last exercise.
Yeah, this is.
How many more questions?
So only this much, so only 10 questions are there. From only this fourth part is there, and this fourth part contains 10 questions. And these are very important questions. Yeah, do you note down this part?
Yeah.
So again, this is a mixed question. So we will write everything in the form of sin inverse, right? So LHS, we want to prove this LHS equals to RHS. So we will write LHS first, and LHS is this thing. So we will write everything in
We
the
can
form.
write cosec minus cot is 1, right?
No, no, no. We cannot write cosec theta as part, right? Cosec square, cosec.
Yeah, cos no, that's the identity, right? Cosec square theta minus cot
Yeah.
square theta.
So, but we don't have cosec square, right?
Oh, so this is a minus b the whole square.
Yeah, a minus b. Okay, so but first we have to change all these things in form of sine cos. So this would be 1 by sine theta, and this is cos by sine, right?
Okay, so whenever we get identities like that, so we have to first put the reciprocal of that.
Yeah, so not the reciprocal, we have to write everything in sine and cos. That is the idea. Write everything in sine and cos. Okay.
Only sine and cos?
Yeah, only sine and cos. Okay, so then we have to simplify this thing. This is sine theta, and this is 1 minus cos theta. This is 1 minus cos theta whole square, and this is sine square theta. Now we can use the identity. So you know that what is the identity? 1 minus cos square theta. So we know that this is a square. I can write 1 as 1 square, right? So this is
Yeah, wait,
1.
here it is said one is equal to 1 minus cos theta by 1. So why did you put it below that?
Yes, yes, what?
It said cosec theta minus cot theta the whole square is equal to 1 minus cos theta by 1 plus cos theta.
Yeah.
So you wrote 1 by sine theta minus 1 cos theta by sine theta the whole square. So after that, you need to put it is equal to 1 minus cos theta by 1 plus. Instead of that, you put it
Oh,
below that.
yeah. So I'm not bothered about. I'm just solving this left hand side. I'm not bothered about this, right? So in place of
But
science,
is it possible if we can do both also at the same time?
first we solve one part and then we think about the other, right? So we'll think about the other one if we don't get the same result, right? So we want to prove this side that this is equal to this thing, right? So we will simplify this thing and then prove it that this is coming out to this one. Or we can also simplify both the things and get the same difference. That we can do also. But up to this point, we are solving this left-hand side, right? Yeah, we got sine square theta and using the identity. What is sine square theta? So in place of sine square theta, I have just put its identity. So using the identity, I got this, right? This is what I have. I'm
Wait,
not.
here you got 1 minus cos theta the whole square. So we can write a minus b the whole square identity.
Yeah, yeah. So we can do that, but yeah, that is. So we have. We should not simplify this. You will see that why this is important. So yeah, we should not simplify this because you see that in the right hand side we have 1 minus cos theta, right? So I
Yeah.
already got 1 minus cos theta in there. So if I simplify this, then I will not get 1 minus cos theta. So that is why I'm not simplifying.
But we can simplify it, right?
Yeah, yeah, we can simplify. So we can write a minus b square as a square plus b square minus 2ab. But we already got this 1 minus cos theta. So we don't want to yeah, complicate things further because this is already matching with right hand side, right? So then we should not simplify this. Okay, so now coming at the denominator. Denominator is 1 minus cos square theta. So I can write 1 as 1 square minus cos square theta. So this is a square minus b square. So this is how much? That would be a plus b and a minus b, right? So I can write this thing as 1 minus cos theta whole square and 1 plus cos theta and 1 minus cos. So you see that this is a square, which means that this is 1 minus cos theta into 1 minus cos theta, right? So 1 minus cos theta I can cancel, and I will get this thing, which is exactly the RHS. Right, so this is what I wanted to do. So I took
Is it
LHS.
fine if you can explain it once more?
Yeah, which part you want me to explain? Which part? So first,
Like the LHS part.
yeah. So I want to prove my LHS is equal to RHS, right? So I want to prove that whatever is the left hand side, that is equivalent to this right hand side. So let's say I take the LHS part. I take the LHS part and then I simplify this thing. And if I am getting the RHS, then it is proved that LHS is equal to RHS, right? So
Yeah.
I took this LHS and I wrote everything in sine and cos, right? So when I saw this LCM, I got in the numerator this thing. In the denominator, I got this thing. So sine squared theta, I wrote it in terms of cos squared theta because using the identity I can do that. And in the right hand side there are cos theta everything.
So sine square theta, you wrote it in the terms of identity. 1
Yeah,
minus
1 minus cos square. So and we also saw that this RHS contains 1 minus cos theta. So I didn't simplify this, right? And in the denominator, I had this 1 minus cos square theta. So this was equivalent to a square minus b square. So then I wrote it like a plus b, a minus b. So a plus b, a minus b. And then this part was cancelled. So I got this, which was the RHS. And, is this thing clear?
So you wrote after, okay, wait. So the last part you wrote 1 minus cos theta by 1 plus cos theta. Is it because here you wrote sine square theta, you wrote it in terms of identity 1 plus cos?
Yeah. So I'm from here I'm getting here, right? And
Yeah.
from there I'm getting. So 1 minus cos square theta is 1 plus cos theta, 1 minus cos theta using this identity, right? So a plus
Yeah,
b.
but how is it a plus b, a minus b identity? Because here for a plus b, a minus identity, it should be 1 square minus cos square. Right?
So 1 square is what?
1.
So I can write 1 as 1 square, right?
Yeah.
So you have 1 square, which is a square, and then you have cos square, which is b square. So you have a square minus b square. So if you have a square minus b square, you can write a plus b. And what is a and b? A is 1, b is cos theta.
Okay. So after that 1 minus cos theta and 1 minus cos theta, you wrote below 1 plus cos theta and then 1 minus cos.
Yeah. So this is a square, right? A minus b whole square. So I can write a minus b whole square as
As
a minus
is
b, a minus b, right? This is a minus b whole square, right?
no, a minus b whole square is a square minus 2ab plus b square, right?
Yeah, so that is the identity. But let's say I want to write 5 square. So I can write 5 square as 5 into 5. So I want to write a minus b whole square. I can write
So you
a
are not
minus.
using identity over here.
Yeah,
You're
I'm
using
not because I don't want to change this 1 minus cos theta into something else. I want this 1 minus
okay,
cos.
okay.
That is the right.
But we can use identity, but
Yes,
it will just get complicated. So
yeah, it will complicate. Yeah, that, yeah. And in the last class, you didn't attempt test classes.
there was classes.
Yeah, yeah. So I told you that there is this classes. Right?
Oh, I guess I forgot because I didn't.
Oh, oh, yeah. Yeah, please
Today,
note this.
is it there today?
Oh, no. So in the next class, on Saturday, yeah, please note this thing down, and it's very good that you asked.
So is the main thing here we have to prove LHS is equal to RHS? Hello.
Yes.
Yeah, the main thing in this question is that we have to prove LHS equal to RHS.
Yeah, yeah. Because if you want to prove that there are two sides, right? Yeah, if there are two equations, so there would be one left hand side, there would be one right. So if these two are equal, then yeah. So this is what we have to
So
prove.
in the other questions also the same thing. You have to prove that it is equal to that.
Yeah, yeah. So we have to if we get LHS and that is fully simplified, then we have to simplify the RHS. So in some cases, we have to simplify the RHS part also. Yeah. If we are simplifying the LHS and we are getting the RHS, then it is okay. But if we are simplifying the LHS and then we are not getting the RHS, so it means that we have to simplify the RHS. That is, yeah, please.